So, welcome everyone. So my name is Labeis. I'm the CEO and founder of technology company REGnosys. We've been working as ISDA's technology partner and more recently ISLA and ICMA on first developing the common domain model. And what we want to show today is a very direct production implementation of the CDM, which is actually an industry implementation of the CFTC Rewrite. So we'll get right into it. So why does it matter, and what is the role that open source software and FINOS, for that matter, played in making that happen? So first of all, the CFTC Rewrite in figures. In a nutshell, it's big and it's costly. So here are a few fun facts. It consists of 175 fields, of which a number are reusable, thankfully. It's spread over 230 pages, scattered across 3 documents. Good order of magnitude for a large tier 1 institution for implementation is in the order of $10 million. And it went live, as luck would have it, Monday this week. What I'm about to show is directly demonstrating what happened for the CFTC Rewrite, but it's not confined to that. The SEC is changing too. Its changing is aligned. Canada is also changing more or less in the same way with 13 extra regime-specific fields. EMIR refit is going to go live in April 2024. There are even more fields to report, more than 200. Thankfully, about a half are actually overlapping with the CFTC. And there is an array, or a barrage, shall we say, of further changes that are coming across the G20 in the next few years. Now, what is DRR, Digital Regulatory Reporting? So it's effectively a groundbreaking industry-led RegTech program that lets financial institutions slash billions of dollars of reporting costs and risk by working together in open source. So what that means is that DRR firms are digitizing, which means effectively coding the reporting logic, and they are sharing that code with others, hence the circle around. It has a few logos on there. In reality, there are more than 30 financial institutions that have been participating to the program, including a number of global banks as well as trade repositories, which are on the receiving end of those reports. Now, where open source is important, all of this has been open source at heart and from the get-go. The DRR ecosystem leverages 2 FINOS projects. The first one is the CDM, as I mentioned, and the second one, the clue is in the name, it's Rosetta. So about the first one, the common domain model provides a standardized representation of trades and events through the transaction lifecycle. You've probably heard that over and over ad nauseam since this morning. So those transaction data are effectively inputs into the reporting process. Now, Rosetta is a language, also known as a DSL, domain-specific language, that effectively allows business and regulatory experts to translate reporting rules into executable code. Both those projects, the CDM and Rosetta, apply a software engineering technique called domain modeling, and they apply that approach to the regulatory reporting domain. Interestingly, so both the CDM and Rosetta are in the process of being contributed to FINOS, as you've heard earlier. The output of DRR is also open source, although not under FINOS at this point in time. And upstream from there, the CDM and Rosetta are actually themselves based on a modeling framework which is held by another open source foundation called the Eclipse Foundation. We use EMF and Xtext. I'll spare you the acronyms, but effectively, it is open source at heart. Okay, so first, 2 sections in that presentation. We're going to talk first about how DRR got built, and then we're going to talk about how DRR can get consumed by users. So first, building DRR. So this is a collaborative industry effort that is being run by industry experts. So how rules are coded. So we're going to step a little bit into the anatomy of a reporting rule in DRR. Effectively, a reporting rule binds 2 components together. The first component is the functional logic of the rule, which is machine executable. So non-ambiguous, can be executed by a machine. And then, and equally importantly, a specific reference to a document or set of documents that support that logic. So this can be regulatory text, but it can also be guidance, technical specifications, you name it. And effectively, the Rosetta DSL is a purpose-built syntax that allows regulatory experts, business analysts, to read and write that functional logic. So you see an example on the right-hand side of those two components. On the left, the regulatory reference, and on the right, the functional logic bound together. So how do we go about building an entire report like the CFTC Rewrite? 3 components: what, whether, when. So what is what to report? Those are all the reportable fields. So those are captured by field rules. Whether to report is eligibility rules. Should I report or not that trade for that specific regime? And finally, when to report, also called timing rules. So this is what you see at the top on the right: what, when. What, whether, when. The field rules are bound together into an overall report data type. So that's what you see on the right at the bottom. In this case, it's the CFTC report data type. And that data type contains all the fields as attributes, and it also contains its own validation logic. Is this field optional, mandatory? How many do I need to have? Are there specific conditions linking presence of attributes versus other? What is the type of fields, and so on? DRR follows a test-driven approach, and that is fundamental. So what that means is that every bit of logic that is implemented in DRR is run live on test packs. So test packs are effectively synthetic data sets. In fact, they are anonymized data sets that are provided by the digitizers, so the contributors around the project. And those test data are used to test the reporting logic in real time. So each test sample comprises 2 components. First is the inputs. So those are the trade events. This is where the CDM comes in. The trade events are represented as CDM data. And second is the output, which is the expected report as per the regulation. And this is driven by the data type that we just saw earlier. So it's being projected into that data type, in this case, the CFTC Rewrite report data type. Now, what Rosetta does is it abstracts all of the machinery that is required for real-time execution away from the user, so that the business analysts and the regulatory experts can focus on implementing the logic, providing the test pack, making sure that everything fits together. Okay, finally, on constructing DRR, how does this get distributed? Again, open source at heart and open source in its output. So that the output, first part of the output, which is open source, is all the model components. So rules, data types, report definitions, also the test packs, extremely important. What is also open source is all the generated source code. So by default, code generated into Java, but effectively that code is directly usable to build compliance systems, and directly usable by either end users, can be the financial institutions, the reporting firms, but also by vendors in the regulatory reporting space. Not open source, but freely available, and very important, is that reporting code that we just saw earlier is also packaged as hosted API. Those hosted API are provided for testing purposes to the industry, freely available. But it's just, if someone wants to get going, test an API, send the data, get a report back, they can do so within a matter of minutes. But it's not for production system because it doesn't have the right latency and other and throttling that would be required for production purposes for obvious reasons. Okay, so that's about how DRR got built. Okay, so a lot of you probably in the room are also consumers of that. You know, how can I make use of that great asset that has been built in open source? So fortunately for you, we have an example of a live production implementation use case, and this actually went live on the 5th of December, so Monday this week. And it went live smoothly, which may be a first for a regulatory project. Okay, so the reporting pipeline. So this is how firms consume DRR. So basically, you need to get to the end-to-end in 4 steps: translate, enrich, report, and validate. And effectively, what at each steps, what Rosetta allows you to do is to abstract the business logic away from the application layer. So we're going to step into each of those steps in a second. So first, translate. Oops. Sorry. let me dwell on that slide just for a little bit. So translate is how you map your internal data models to CDM. Generally, like the industry is not natively CDM. They all use existing data messaging formats. Those can be mapped to CDM. It uses a built-in feature in the CDM and in the Rosetta DSL. Then second, you need to enrich those data. So those data need to be enriched with either public or private data sources. And the APIs by which you do the enrichment is actually specified in the which means it's standardized, and you can do that again using the Rosetta DSL. The third part is how you report. So the functional expression of the reporting rules in the regulatory text is what allows you to report. And effectively, it's using the Rosetta DSL ability to express logic, and all of that gets translated into executable code. And finally, validation. So it's the same validation logic which is often contained in the technical specification, can be encoded in the model and using the Rosetta DSL's ability to express logic. So what the next slide shows how all this can be put together on an actual implementation. So this is a live implementation that is actually, and here I need to make an important disclaimer using Rosetta services. So some of the components, and I'm going to say which ones they are, some of the components on that slide are not open source. They are provided on a commercial basis. But as I said, like everything that gets distributed or either free or available is as per what I mentioned on the previous slide in how DR gets distributed. So from left to right, the first step is that the client staff uses the Rosetta service to build source code for each of the required data pipeline. So data pipeline, think of it as how you get data from end to end. So the CFTC Rewrite is one data pipeline. I'm getting CDM data as an input, and I'm reporting to the regulator as an output. In this case, we have, in fact, three data pipelines. Translate, enrich, and report are all data pipeline. So all of those get coded as source code, as a model, in a client private repository. So that's the second step. All that source code is now hosted in a private repository at the client. And the pink box that you see all around that is effectively for the ability to do that and to develop their own private extension of the model. This is where it requires some services that are provided on a commercial basis. On the third step, on the right-hand side, you have how those data pipelines get deployed. So many deployment options available. One popular one that we see is that data pipelines are packaged and deployed as container. We use Artifactory as our software artifact registry. And effectively, the client can pull that software and embed it on premises within a microservices architecture, for instance. So that software gets embedded directly within their compliance implementation. So Rosetta or the CDM does not provide the compliance implementation. The client builds that, but they can directly embed all of the logic as part of that compliance implementation. They don't have to re-implement it. And this can be deployed, well, in that particular example, on-prem. But some clients, hopefully in future, will be keener to migrate that even on a hosted basis in the cloud. And that's it. And that's a way by which a firm went live with the CFTC Rewrite earlier this week. So we're going to talk a little bit about each of the steps. So translate, enrich, and report. So how do you translate from firms' internal models to CDM first? So this is, as I said, a built-in feature in the Rosetta DSL that allows to map to external models. Very important. The CDM is distributed with a set of synonyms and test packs that allow you to ingest from public model sources. So an example is the Financial Product Markup Language, or FPML, which is widely used by most firms, generally in their confirmation systems. They generally use variations of FPML, but essentially it's based off FPML. And effective firms can extend these public synonym sources and the test pack to map to their own. So that's the first step. The second step is enrichment. So how do we enrich CDM data with static reference data? So why do we need to do that? Typically, front office transactions, which is effectively the data at source, they usually need to be enriched with static data before reporting. This can be legal entity reference data. This can be, so those would be publicly available, but those can be privately held. For instance, in many reporting regimes, you need to report personal information about the traders who did the trade, passport number, etc. So those would typically sit in HR systems. So what DRR leaves the choice of data source that implementers want to use. However, the API, which is the inputs and outputs, can be standardized and specified in the model, and this is exactly what we do. So three steps to do that. First, we define a special annotation that marks external APIs in the model. It's called external API, very original. Then we define that external API by its input and output. So the example that is shown on screen is a glyph call, so that's a call to the legal entity database, which is public, which is called glyph. So you would pass in a string as an input, which is effectively LEI, and you would get back information from that database about the name of the entity, the country, and other sorts of useful information. And finally, you can use that API as a function in the model to enrich the data. So in this example that is shown on screen, it's ellipsized for obvious reasons, but basically I pass in transaction input, which is not enriched, it's coming from front office system, and I have logic that calls the enrichment API, connected to glyph, and enriches that data with LEI data, and it gets through the rest of the process. So we went through translate, enrich, and finally report. So that's, whoops. Well, actually, that was the step we saw earlier. So that's where people can either deploy it on-prem or hosted. And if they deploy on-prem, they just pull from our software registry. And which brings me to the conclusion. So hopefully we will have time for questions. So what's next for DRR and how FINOS can help? Well, in a nutshell, it's all about collaboration. So the image on the right-hand side is effectively my lame attempt at representing a quote that I like, which is the difference between stepping stones and stumbling blocks is the way you use them. So what happens in the next couple of years is that a wave of regulatory changes are afoot across the G20. Next is EMIR refit, compliance date, April 2024. Many in the room will be all too acutely aware of that. And also anticipated in 2024, 6 or 7 other regimes across the globe. Those could be stumbling blocks, and usually they have been stumbling blocks for the industry. Now, the pitch that I'm giving to you today is to say, no, this is actually a stepping stone. This is a massive opportunity for the industry to change the game once and for all on regulatory reporting by doing this. And how to do that? It's through open source collaboration. This has all been about how the industry comes together, collaborates in open source to solve that problem once and for all, and it's been proven on a production use case. This has involved firms, but what's interesting is that, and we are seeing very, very positive vibes at the moment on that, is increasingly it will involve regulators. I would hesitate to go so far as saying, hey, in a couple of years' time, the regulators will directly provide regulations as code. But that being said, there are some regulators that have been toying with the idea, in particular the European regulators and also some in Asia. That would obviously bring substantial benefits on both sides. Regulators have a self-interest in making that happen because it is the way for them to ensure absolute data accuracy and quality and comparability on the reporting regimes that they supervise. And that's it. I'll leave you with that thought, and I'll take any question. Sorry, I forgot to say, if you want to see a live demo of that in action, table number 5, so my colleague Nigel is also at the table with me. Those are QR codes if you want to scan them, if you want to connect us on LinkedIn. Questions?
This being
So I'm just going to repeat the question. So the question is, can this be used for internal risk management purposes if a firm wants to embed rules, for instance, within like limits in trading, for instance? So the short answer is yes, absolutely yes. So this particular example is using all of the functionalities that you've seen to build something that is common across the industry. And the benefits are obvious because it means everybody can collaborate. But the same technique can absolutely be used to implement and enforce rules almost like at source in systems. And those may be private to a particular organization. So yes, absolutely. Obviously, it doesn't necessarily have the same, the extra kick of that industry collaboration that makes everything even more efficient. But yes, definitely having that transparency over, this is a rule, it's being enforced natively. And by the way, because the rules are bound to specific text and references, I can actually link that to my internal policy as a firm. So that would be a very powerful application indeed.
Thank you. I wanted to ask about enrichment. So I think there are a lot of challenges about enrichment part, right? Can you hear me?
Louder?
Can you hear me? Oh,
yeah, better.
Now you can hear me. I wanted to ask about enrichment. So, and the challenges around enrichment. And what happens when, if it's either external or internal, you cannot enrich and the source is in a separate repository, how is handling to recognize when the data is available to fix the reporting? Yeah, so the question is about enrichment and essentially how does it work, especially if we are enriching with private API. So the way to, and we have that exact use case with some clients. So the API was defined in the model, so the inputs and outputs. So I like to take the example of the HR systems. If we are to enrich data with private information about traders' name and passport number and all this kind of thing. So you can absolutely standardize that call. You need to pass me in an employee number, and I'm going to return you this set of information. And then we define an address for the API. And then the system will automatically recognize the address of that API and make that call. And that sort of call to the API gets embedded in the software that is being pulled in the container. So that's exactly, and we do some calls, not just to Glyph, a public database, but we do some calls to internal APIs. We have an example of a firm who's also using that. They have their own eligibility engine. And basically we are making calls as an API to an eligibility engine, again, which is modeled in exactly in the same way as what I showed on Glyph, for instance. How does it handle exceptions? I don't know. It's the honest answer. I'm sure we've done something, but I'm not sure what it is. Nigel, do you know how we're doing it?
What Ian said.
Okay, good.
So we're writing validation conditions, but ultimately we're delivering a model and a lot of software. But yeah, if there's technical integration issues, then that's part of the testing and build to make sure that those calls are going to work and don't fail. That's implementation.
Hi, thank you for this presentation. I think I have two questions. The first question is, you mentioned that there are some firms that went live with DRR. Can you talk about how many firms and how long it took for the implementation and just the general experience? And then my second question is, as you may know, CFTC Phase 2 is coming up on the unique product identifier and also ISO 20022. Are you guys planning to use DRR for that? Thank you.
Thank you. Yeah, two very good questions. So What's interesting is that because it's an open source project, we don't necessarily know the exact number of firms who are using it and how, and that's the beauty of open source, and we don't need to know. What I can tell you is that we definitely have, we know of at least one firm who went live directly with the code provided by DRR as their primary implementation. We know of at least one other firm who has used the code for benchmarking. Effectively, they have an internal implementation, and they benchmark that against what was provided by DRR. We know of at least another firm who had even a bit more light touch approach, and they used the test packs as a way to benchmark their implementation. So they didn't use the code, they just used the test packs. These are the inputs, this is the output. If I run that through my primary implementation, do I get the same? And because all of this gets distributed in open source, then, open season. So we know of at least those three. The CFTC was the first new trade reporting regime that went live, but all of the G20 is going to change across the next 2 to 5 years. So the dynamics at the industry level, as I said, there were more than 30 financial institutions around the table and having contributed to building that. Only some of them kind of went live with it first time around, but hey, it's the first time. So, early adopters take a leap of faith. Others, are looking to see what happens. Based on the success of that first rollout, what we expect is that with EMIR refit and the flurry of other APAC regimes that are coming next year, that we're going to see, my lower bound estimate is probably, half a dozen firms who are going to use that as their primary implementation, the code. That's my floor. There could be more. Sorry, you had a second question, and I forgot what it was. Oh, no, ISO 20022. Yeah, okay, so as you know, ISO 20022, reporting to the CFTC was initially programmed to be ISO 20022 compliant. ISO 20022, the technical specification was not there, early enough for that to happen. So the CFTC effectively provided a relief to the industry and said, even if we go live December of this year, ISO 20022 will not be until December of next year, I think. And in direct answer to your question, yes. And that's also going to apply to EMIR refit. Most of the next ones are going to be ISO 20022. So DRR will also include that, last mile, which is translation into ISO 20022. And that was one of the biggest driver for why we, at some point, we decided to change the way we were looking at the output of the report. And now it's a data type with like attributes, types, cardinality constraints, validation. We effectively have it as a model component because we can then take that and map it to the ISO 20022 model. So that was one of the drivers for doing that. I don't have my glasses. I don't see what's at the back. Are we finished? Stop. Yes, we are. Okay, thank you very much.